Okay, in this video I have a pentagon. They give me the area and I want to find the length of one of its sides. Remember, it's a pentagon, so all the sides are the same. Now we've very few tools, I suppose, or methods to find aspects of pentagons, such as areas and lengths and things like that. So for that reason I'm going to divide this into triangles. And all the triangles are going to be the same. And all those angles in the middle will add up to 360. And there's 5 of those vertices here. So if I divide 360 by 5, I will get 72 degrees. Okay, now I'm going to concentrate on one triangle. Oh, there it is. And I'm going to just label the size of that triangle, or sorry, the vertices. So that would be 72 degrees. Now remember, it's an equilateral triangle, which means these 2 degrees will be the same. So 180 minus 72 is 108, and then divide that by 2, which is 54 degrees. And remember, I'm looking for that side. Now here's what I'm thinking. I know I could find the area of this triangle very easily. Okay? The area of the whole lot, or 5 of them, is 600. So the area of one of them is 600 divided by 5, which is 120 centimeters squared. Now if I could just get the height of that, I could use my half base by height formula to work back and see what this height actually is. So I'm going to call that height y. Let's see if I can find it. Remember, in right angle triangles I have many tools to work with, okay, like Pythagoras' theorem, SOHCAHTOA, things like that. So I am going to take that triangle, but I'm just going to concentrate on half of it. So we'll take the triangle again. This time I'm just going to half it. I'm going to call that y. That's what I'm looking for, that height. I'll label what I have. This is 54 degrees. This whole length here is x. If I just concentrate on this bit though, I'll call it x over 2. There's a right angle. And this here, well, the whole lot of that will be 72. So this here is 36 degrees. Right, I want to find y. If I label my sides, so there's O in relation to this angle, there's H and there's A. Can I find y? Well, I want y, I have A. So I'm dealing with let's trigonometric ratios first. So could a hungry, stupid ostrich have taken over America? And we see that tan deals with O and A. So the tan of 54 degrees equals y over x over 2. The tan of 54 is 1.38 equal to y over x over 2. I want to know what y is, so if I divide this side by x over 2, or sorry, multiply this side by x over 2, multiply by x over 2, get rid of the x over 2, if I multiply this side by x over 2, I'll have 1.38 multiplied by x over 2. So the height of my triangle is that. Okay. Now I'm going to concentrate on my area. So remember, area of a triangle, area equals half the base multiplied by the perpendicular height. Okay, well I know what the area is, it's 120. Half the base is x, and the perpendicular height is this. So 1.38 multiplied by x over 2. Okay. And now we're just going to do a bit of algebra to see if we can find out what the x is. Okay. So I want to get rid of the half and multiply by 2. Multiply by 2 on this side, I get 240 equals x multiplied by 1.38 x over 2. Multiply by 2 again, I get rid of this 2. So multiply by 2 again, I'll have x multiplied by 1.38 multiplied by x, and that equals 480. Just to type that up, 480 equals 1.38 multiplied by an x by x, x. squared. If I divide this side by 1.38, I have to divide the other side by 1.38. I get 347.82, and that equals x squared. Just need to get the square root then of both sides, find out what x is. So square root of this is x, and square root of that is 18.64. So 18.64, and it's centimeters because we're talking about centimeters squared. So that there is 18.64. Okay. And the reason I know it's centimeters is because we were told it's centimeters squared at the start. Okay, so that's that, guys. Thanks. Right, next question, we have a trapezium. And very simple, in our logbooks there is a formula for the area of a trapezium. We have the base, which is B, we have the top flat is A, and we have the height then, perpendicular height, which is H. And all we do is throw it into this formula. So area equals, A is 8 plus B, which is 10 all over 2. And we multiply that by the height, and so the height is 7, I should have put in. So area equals, that is 9. The next question then is to find the volume of a pyramid with any base. So here's a pyramid, so to find the volume of it, it's 1/3 multiplied by which equals 32 centimeters squared. Now let's say over here a pyramid with any base. So for instance, if we had this kind of a base, but it all went up to a point to the top, so basically a pyramid like that. Okay, this next one then is we have a frustum. In our logbooks we have two formulae. One is to find the surface area, the curved surface area that is. The other is to find the volume. All we really need here is h, which is the perpendicular height, the radius of the bottom part, the radius of the top part, and the slant height. Okay? And if we have that, we can throw what we need into those similar triangles to solve it also. So let's just look at this question. So in this question we have a frustum, right? Now just pretend that I was to carry up this cone just like that, okay? Well, I could really look at this triangle here, okay? So I'll draw that. So I'm just interested in this half of that cone laid kind of flat on a table, the way I can just see it as a right angle triangle. Right, the height of the whole thing we'll say is h. So watch this. I can first concentrate on the big triangle. Okay, now these triangles are similar. Okay, similar meaning that they have the same angles. They may not necessarily be the same size. They're not congruent, or they may not be congruent, but they're definitely similar. 3 angles of each triangle are the same. Okay, So with that in mind, I can say that in the big triangle, this height, we put it on top here, and the base then we put it on the bottom here. So this ratio, h minus 8. So if I cross multiply, which is what I can do if I'm finding one unknown, so cross multiplying, I do it this way, I get 4h. Do it this way, I get 6 multiplied by h minus 8, which is 6h minus 48 equals 4h. Get rid of the 4h. We have get rid of the 4h here as well. We have 2h minus 48 equals 0. We'll add 48 to here equals 24. Okay, so that means the whole height of this is 24. So I'll just draw out this cone again. Alright, there's the bit that we have, this frustum here, but now I know the height of the whole thing. The height of the whole thing is 24. Okay, so if I get the area of the whole cone, then get the area of the smaller cone on top, and then take it away, take the area of the smaller cone away from the bigger cone, I'll be left with the area of this frustum. Alright, so shouldn't really do it. Okay, so the area of a cone, sorry, the volume of the cone, I said area, I meant the volume, so start that again. If I get the volume of the whole cone, then get the volume of the small cone on top, take one away from the other, I'll be left with the volume of this frustum. I'm able to do that because I have the height of the whole cone. Okay, it's 24, I'm just have to find it. I have the height of this now, it's 24 minus 8, which is 16, and I have the two radii from over here. Okay, so let's get the volume of the big cone first. Volume and that is 904.32 centimeters squared, and that's the big one. Small one, same formula, volume equals 1/3 pi multiplied by 16 multiplied by 16. And that is 267.95. Okay.